Hey, what's up guys? This is Akshay from AS Learning, and today in this video we'll be seeing how to do clustering with GenAI. Okay, so clustering is a traditional ML task, and GenAI is a new concept trending into the AI world. Okay, so we'll be seeing how to do clustering with the concepts of GenAI. Okay, so let's get started with the code. First, here I've done the installation of OpenAI. I'm using OpenAI 1.52, okay, version 1.52. Then here I'm importing the required packages. Here you can see from AST import literal eval. So what is AST? AST is abstract syntax trees, and here I'm using literal eval. It actually evaluates an expression node or string containing only Python expression. Okay, so what is the meaning of this thing? So let me give you an example and how we are going to use it. Okay, so let's say if you have a list, okay, 0 1 2, but it is quoted in strings. So how to convert this into a list? The first thought which might come in your mind is, okay, let me use a list casting function, but the list casting function will also consider this square and this arrow. Boom. Now what to do? Now let's say if I have a data in this format, which we generally have embedding data in this format, and they are stored into storage in the form of string. How to get the embeddings? How to cast it out? So the solution to the problem is you can use literal eval from AST, that is abstract syntax tree package of Python, and it does the evaluation for you. Okay, let me see if normal eval works. I've never tried it. Even this works. Okay, you can use normal eval also, or you can use literal eval. Okay, there's some difference between literal eval and normal eval. I think literal eval is some kind of a subset of eval. Okay, but you can check more on it. Okay, then here I've imported user data from google.collab. So let me explain what is this. So we can store our sensitive keys like Anthropic key, or maybe Azure OpenAI key, or Pinecone key here in secrets. Okay, and the keys here are not washed off in real time. So let's say if I create a new notebook, the keys are retained here. Okay, and even if when you want to pass on your notebook to some other guy or maybe share, then sharing the key is a sensitive thing if you straight away use it in the code. So the best practice is just add a new secret key here, give it the access, and then accordingly just import it using user data.get secret name, which is your name given to the key. Okay, it's a very good practice. Then we have seen the installation of OpenAI. Here I'm using 1.52. If you are using code generators for generating your code, generally they generate the code with the OpenAI compatibility less than 1, and hence you might see a need to migrate the code. Okay, just giving you a heads up, like the problem which I generally run into. Now we have seen AST OpenAI user data. Next thing what we'll be doing is we'll be straight away jumping to the data set, and we'll be seeing how we are performing the clustering here, coming to the elephant in the room. Okay, so this is the Amazon food review data set. Here we have the product ID. Here is the user ID. This must be masked, I guess. Definitely masked. Okay, this is the user ID of the user who is giving the review to the product. The scoring he gave out of 5. Okay, short summary, textual short summary, the entire brief summary, and here I have combined the summary and the text, okay, into combined, because this is what is getting embedded. Embedding is not just done on text, it is done on summary plus text. Okay, you combine them and the number of tokens needed to embed this combined column and the actual embedding for this combined text. Okay, now just food for thought. Okay, if you have reached here in the video, I would like to ask you, can you tell me the max and min value of the individual numbers into embedding? Have you ever checked it? Have you ever checked the distribution of these numbers inside embedding? Just give me a thought, and just have a thought on it, like what is the max min and what is the distribution of these numbers in embedding. Okay, now this is what the data looks like. We saw what is the data. There is one more thing where people get confused. People think that token is a word in a sentence, but that is not the case. Token is like, you will say, part of a sentence. It need not be a meaningful word. Okay, uh, I think there was a concept in NLP, lemmatization and stemming. Yeah, so how the way stemming does it is crude chopping of the sentence, and these crude chops are token. Okay, and next thing is what we do is, now because this is a list of numbers with string as d type, so here I am applying literal eval to evaluate the numbers and then converting into an NP array, an ND array, n dimensional array. Then I am doing vertical stacking. Okay, vertical stacking is stacking the embeddings one after another in vertical format and creating a matrix. Okay, matrix shape is 1000.1536. Now why 1536? Give it a thought. These are some little interview questions, I think, which separates a good GenAI guy from an average GenAI guy. You must know why 1536. If you don't know, you need to work more. Okay, so 1536 is the embedding dimension of OpenAI. OpenAI ADA 002 model. Okay, so if you have used ADA 002, the text embedding ADA 002 model of OpenAI to embed your text, the output of that embedding will be the dimension of 1536. Okay, there are other embedding models of OpenAI also. Text embedding 3 large, text embedding 3 small, recently got released with 4.0, that is 4 Omni. Do let me know if the do check if they also have the same dimension size. I don't know the answer to this question. Okay, now here we have a matrix ready. So we have 1000 rows with the embeddings of this summary and text. Okay, now before going on to the task, let me explain the use case first. I jumped a bit. So the task here is to cluster out the users. Okay, we have the users giving us reviews, and we want to see what is the cluster here. Can we segment out the customers? Can we create clusters? Customer segmentation. So what we did is, we took help of this text, we embedded them, and now we have the matrix ready. Now we are using k-means. Here I have kept the normal number as 4. There is no logic behind the number here, but you can play with concepts like elbow method and silhouette score and other things, and just come up with the optimal cluster maybe. Okay, and here I have initialized k-means, fitted it out, calculated the labels, and created a new column of cluster. Initialization here is k-means plus plus. So you must know what is the difference between k-means and k-means plus plus. This also separates average ML guy from a good ML guy. Okay, so what is k-means and k-means plus plus difference? In simple terms, it happens in the initialization process. In normal k-means, you do random initialization. Sometimes the centroids are not, if they are not initialized properly, there is convergence issue. The convergence is slow and also not appropriate. So there is an advanced technique of k-means in which what happens is the first centroid is initialized randomly, but later on, by seeing the probability distribution of the distances of the points, the next centroid is picked. So it just makes sure that the next centroid is farther from the current pick centroid. Okay, you can read more about it. Okay, so here I just did a norm. This is just a normal group by cluster, score mean, sort values. So do we get any idea from this? We get an idea that cluster 1 seems to have given high score. Other are pretty much same to each other. This also gives the idea that most of the people have given 4 ratings. Okay, so let's see more on it. Let's visualize it. So for visualizing, because that it's 1, 5, 3, 6 dimensions, I need to bring it into 2 dimension. So here I've used Tesne, T stochastic, I don't know. Can just what is Tesne? Tesne is distributed stochastic neighbor embedding. Okay, this is Tesne. So I've initialized Tesne, kept number of component as 2 because we want a mapping into 2D. Perplexity here is 15. What is perplexity? So it, in simple terms, I'll say it, perplexity decides how much coverage you need to give to local structures and the global structures while doing the dimensionality reduction. Okay, so it's an indication of how much importance you're giving to local points and global points. Okay, you can read more about perplexity. Okay, it's a very important factor for creating the dimensionality reduction. Okay, here in it is random, learning rate is 200, and here I am fitting the Tesne, and here I've created a scatter plot out of it. So from this cross marks, here are the centroid points. Here we can see that the red one is quite segmented. I'll say only one point is here, others are quite segmented. Even the blue one is quite good, green is scattered, and even purple is good. Okay, now we see that there are clusters being created from the embeddings. Red is 1, blue is 1. The clusters are there, but we don't know what these clusters are. So can we try to find out that what exactly are these clusters? Like what exactly can we give, what kind of name can we give to this cluster? So again, we can use the concept of GenAI. Here we are using prompt engineering now, and what we will be doing is, here I am initializing my OpenAI, and once my OpenAI is initialized, I am telling him just see the customer reviews. I have picked the top, like the sample here is 5. You can increase it more. Just see the random 5 samples of the clusters, and can you think of a cluster name to it? Okay, the parameters here are penalty present 0, frequency penalty 0, and then here I've printed it out. So here we can see the names coming for its clusters. Cluster 0 is food product, cluster 1 is all the reviews are about different types of product purchased online, so different products. 2 it has given to be pet products, and third is coffee products. Okay, so this looks good now. Food product, although food product is like a superset, but coffee product and pet products are being separated out. Okay, anything more in detailed concept which I can add here? Yeah, so what is this parameters of frequency penalty and presence penalty? Just think of it it in this way that presence penalty makes sure that the already existing tokens should not be repeated enough, the presence should be less, and frequency is like the occurrence of the tokens. Okay, looks sounds similar, right? Frequency penalty and presence penalty. Hmm. I think maybe read more about it. Okay. Similarly, when temperature and top P, they are also quite similar. They both impact the randomness and the creativity of the GPT-4 output. Toppy, it is somewhat similar. It takes into consideration the probability coverages of the token options. Higher the top P, it makes sure that all the tokens are given the probability to be in the output of the GPT-4o. Temperature, it's like controlling the randomness. If temperature is uh, less, I think it's more deterministic, and if it is higher, it is less deterministic. Okay, so this is what I had in this video. So in short, what we saw, we had a data set of reviews. We created, now although in this data set we have embeddings created for it, but there would be one more process of creating the embeddings from this reviews. So we had the embeddings in place. Once the embeddings are in place, then we created the clusters, and we also tried to name the clusters. Okay. So that's it, guys. That is what I had in this video. If you learned something new, give it a thumbs up and stay tuned to AS for more such amazing tech stuff. Take care. Peace out.